Pre-Calc, it's 10-116. I really loved this one because they wanted me to write sigma notation for this. So they said, write the following expression using summation notation. So summation notation is that notation where you go like this, and n's going to go from something to something. Like in this case, you might not know yet. I wrote 9 and 10 here, but when you look at it, they don't tell you the term numbers here. So you have to look for a pattern, and that's what I think is so fun about it. So the way that I start looking for a pattern is I go ahead and I do write at least, I didn't know these two yet, but I wrote this as the first, second, and third term. And then I looked at it and tried to figure out, like, what could I do to this term number to get this? And I realized it didn't take that long to realize there's something going on with some squaring, because that's 1 squared, that's 2 squared, that's 3 squared. So that led me to say this numerator is probably n squared if I call the term numbers n. And then I wondered I don't know if you might have seen this pattern, that this denominator ends up as numerator over here. So that was interesting too. See, even over here. So then I tried to figure out how can I write these denominators in terms of n, which is the term number. So seeing as they're like this numerator is, well, I'll just tell you what I put. It's n plus 1 is what I figured out. N plus 1. Because this is 2 squared, 3 squared, 4 squared, like it's one more than whatever the term number is. And even this one, if the term number is 9, this is one more than 9. That's 10 squared and 11 squared. So this actually holds true and works. And that's how I knew, like, since the pattern works for the first 3 terms, I knew this one must be the 9th term, because 9 squared is 81. And so now I know that there's 10 terms. So when I do my summation, I want to sum from 1 to 10. And then I think I can just write this. And I think that's about it. Yep, that's it. So that was fun.